All right, let's get into it. We're going to talk about something that sounds super abstract, but its story? It's actually all about grease, steel, and steam. Yeah, we're talking about why things just fall apart, why your room always gets messy, no matter what, and why the entire universe seems to be on this one-way street to, well, chaos.
And hey, if you've ever seen a post like this and thought, yeah, me too, you're definitely not alone. These big sciencey words, right? Entropy, enthalpy, they can sound kind of the same, super confusing. We're just going to focus on entropy for now because its story is, well, it's wild. People usually just say it means disorder, but trust me, that one-word answer barely scratches the surface of the why.
See, to really get a handle on this whole universal law of messiness, we need to take a trip back in time. But we're not heading to some quiet library or a philosopher's study. No. We're going somewhere loud, hot, and honestly pretty greasy. We're heading straight into the engine room of the Industrial Revolution. So let's break it down. What are we really talking about here? In the simplest terms, it's the fundamental reason why things just, well, they fall apart over time. It really just boils down to probability. Seriously, think about it like this. Take a coffee mug. For all its molecules to line up just right to be a perfect, usable cup, there are only a handful of ways that can happen, right? But how many ways can it be a pile of shattered pieces on the floor? I mean, basically infinite. A system is always going to drift towards the state that has the most possible arrangements. Nature, it turns out, is a gambler, and it always bets on the most likely outcome.
And this idea, this rule, that the total messiness of the universe can only ever go up, it's so important, it's got a name. The second law of thermodynamics. It's the boss. It's the reason a gas doesn't just hang out in the corner of a room. It fills the whole space. It's why your coffee gets cold, transferring its heat to the air. And you never, ever see a lukewarm coffee suddenly start boiling on its own. It's a one-way street.
But here's the kicker. This is the really surprising part of the story. You'd think a law this profound, one that dictates the fate of the entire cosmos, would come from some astronomer gazing at nebulae, right? Nope, not even close. It came from engineers who had a very down-to-earth problem they needed to solve, a problem that could make them a lot of money.
So let's get into it. We're going back to the 18th and 19th centuries. The world is being completely transformed by one single machine, the steam engine. And believe me, the people building these things were not thinking about the heat death of the universe. They were thinking about powering factories, getting water out of flooded mines, and making trains go faster. It was all about practical power.
The first engines, they were fine, kind of clunky, but then James Watt comes along with this game-changing idea, a separate condenser. Now, this might sound like a small tweak, but it was huge. It turned the machine into a true heat engine. Suddenly you had a dedicated hot source, the boiler, and a dedicated cold source, the condenser. This idea of a temperature difference, that became the key to unlocking everything.
And this is the point right here. The entire massive field of thermodynamics, it didn't come from a university lab, it was born out of a purely commercial need. How do we get the most bang for our buck from burning coal? It's like this quote says, "Today students just see these clean, elegant equations. The messy, gritty industrial origin story, it's been totally forgotten."
So, to make these engines better, they had to answer a really basic question. What is heat anyway? And tackling that question, well, it triggered a complete revolution in how we think about energy.
The old idea was something called caloric theory. People thought heat was this invisible, weightless fluid that just flowed from hot things to cold things, like water pouring into a bucket. But the new idea, whoa, it was a total mind-bender. Heat isn't a thing at all. It's a form of energy. And this is the big part. It could be transformed into work. It's not just moving around, it's changing its identity. This revolutionary concept got a formal name, the first law of thermodynamics. You probably know it as the conservation of energy. It's a rule that underpins pretty much all of physics. Energy can't be created or destroyed, only changed from one form to another. And once they had that rule nailed down, the stage was set for the next big discovery.
Okay, so with the first law in their pocket, the race was on to build the perfect engine. And the person who really led this theoretical charge was a brilliant French military engineer named Sadi Carnot.
Now, Carnot wasn't messing around with actual nuts and bolts. He was a thinker. He imagined a perfect, flawless, totally idealized engine, one that could run forwards and backwards without any loss. We call it the Carnot cycle now. It was a thought experiment, a way to calculate the absolute, theoretical maximum amount of work you could possibly get from the heat flowing between that hot boiler and that cold condenser.
And this is where it gets really good. Another physicist, Rudolf Clausius, started digging into Carnot's math, and as he was crunching the numbers for this perfect imaginary engine, he realized something was hiding in plain sight, a new property of the universe that nobody had ever noticed before.
He found this weirdly perfect relationship. In that perfect engine cycle, if you take the amount of heat you put in or take out, and you divide it by the temperature when you do it, over the whole cycle, it all perfectly cancels out. It always adds up to zero. Now, for something to stay constant like that through a whole cycle, that means it has to be a real, fundamental property of whatever you're looking at, just as real as its pressure or its volume.
That was it, the eureka moment. Clausius had found a brand new, fundamental quantity of the universe. He gave it a name, entropy. And the craziest part? This profound cosmic property was discovered by analyzing the math of a steam engine. So you might be thinking, okay, cool, a new math property from an engine. Why does this matter? Well, it matters because this discovery, born from steam and coal, completely rewrote our understanding of, well, everything.
See, the role that total entropy always has to increase, that's not just some footnote in a physics textbook. It is the director of the movie of our universe. It dictates the flow of time itself. It's the arrow of time that makes sure things only happen in one direction. It's why an egg can be scrambled, but not unscrambled. It's why an ice cube melts in your drink. It's the reason stars will one day burn out. And yeah, it is absolutely the ultimate reason your room gets messy.
So what's the big takeaway? It's that behind these big, confusing equations, there's a really human story, a story about people trying to solve a practical problem. It's kind of like the Cheshire Cat from Alice in Wonderland, right? The gritty, industrial cat has vanished, and all that's left for us to see is the mysterious, floating smile of the final theory.
And that leaves us with a pretty cool question to chew on. The effort to build a better steam engine accidentally revealed a universal law about cosmic decay. So it really makes you wonder, doesn't it? What fundamental truths about our universe are hiding inside the technology we're building right now?